Hello, everyone. I'm glad that you three are here today for the class. Maybe Ankita will join us a bit later. So let's begin with our introduction. I'm Anil Kumar from Toronto, Canada. And here is a class on advanced functions. We'll discuss transformation of functions today. Mohammed, can you introduce yourself, please?
Mohammed, I'm from Oakville, Ontario. I'm a grade 10 student going to grade 11. I'm taking this course to try to get a better understanding of functions and try to prepare for the future.
Good. Vishruta.
Hi, my name is Vishruta. I'm doing advanced functions to help me understand advanced functions because they're very important.
Hamza.
My name is Hamza and I'm taking this class because I'm going to grade 11. I will take advanced functions next year and I'm just trying to be ahead of my class and get a better understanding.
Very good. So let's begin with the lesson which I have prepared for you. Yes, yes. So I think we'll do inverse of the function because polynomial introduction we did do a bit, right? So we can now take polynomial functions, especially parabolas, and then do inverse also for those functions. Is that clear? Okay. So we'll get to inverse of the functions today. Now, as you know, we talked about functions, which is basically a rule which converts input to output uniquely. So for every input, we have a unique output. That is what function is, right? So, Mohammed, I'd like you to read what is given here.
Okay. Function. Function f is a rule that connects each input x to an output fx.
Yes.
All possible inputs x are the domain of the function. Corresponding set of outputs fx is the range of the function.
Yeah, that is what a function is. Inverse is kind of a reverse operation, right? So the thing is, what happens when we feed in from the output side to our machine? Do we get the same input which resulted into that output? That is what we are going to look into today. Is that clear? So the reverse operation is actually inverse of a function. So basically, you could say that inverse of that function really means that the output should now be x, right? Because we fed in x, we got f of x, and now we will feed in f of x, and we should get x back. That is what the whole operation is, right? So for example, we had fed -1 into a function whose equation was 2x plus 1. So if I define my function as 2x plus 1, and if I feed -1 here, -1 times 2 is -2 plus 1 gives me -1. So I get -1 as an output. If I feed in 0, in that case, 2 times 0 is 0 plus 1 is 1, and I get 1 as my output. Likewise, we can have different outputs for different inputs. The idea is, if I feed in 1, then do I get 0? That will be the inverse operation. Is this clear to you? So that is what we are going to look into now. So basically, inverse function is shown as given here. So f with -1 as a superscript is inverse of a function sign. So you must notice now that we have these arrows which are going in the reverse direction, correct? So the arrows are going in the reverse direction, as you can see here. Output is now being fed to the function. We expect to get the original input, x value. If we get x value, then we say that this is inverse of the function. That operator in between is inverse. It has reversed the operation which was done by the function. Is this concept clear to all of you? Perfect. So what I found is, for this operation of 2x plus 1, which was our function earlier, inverse of this function is x minus 10, x minus 1 over 2. That is the inverse of this function. We will just now see in a minute how do we get x minus 1 over 2 as inverse of this function, but let us verify the result now. So earlier, we had fed in -1, we got -1 as the output. If I put -1 in this x minus 1 over 2, what do I get? I get -1 as -2 divided by 2 is -1. Clear? I do get the same input which was fed earlier, correct? Let us try this value of 1. If I feed 1 here, then what do I get? I get 1 minus 1 over 2, which is 0, correct? So there you see, we do get 0. Is that clear? If I feed in 3, then what do I get? I get 3 minus 1 over 2. 3 minus 1 is 2. And so we get 1 here, and 1 was the earlier input. Do you see that? So if I feed in 3, then I do get 1 as my output. So the same input has become now the output. Do you see that? And therefore, we have verified that the function given is really an inverse of the earlier function. Is this clear to you? So that means what I'm trying to say here is this. Hamza, can you please read what is written here?
Oh, sure. An inverse function is a function that reverses given function. G of x is the inverse of it. Okay. Is that
Continue.
okay? G of x is inverse of f of x of g
Of f of x
g.
is
Yeah. Okay. G of f of x is x.
correct.
It is denoted as f of the inverse
Inverse
of x.
Hmm.
Yeah, f of inverse of x. We can say f of inverse of x of f of x equals to x. Domain of the function becomes range of the inverse. The range of the function becomes domain of the inverse. Only one-to-one functions inverse would also be a function. Okay, that makes sense.
Did you understand all these points? So earlier domain, this was the domain earlier, right? For inverse, that becomes the range. They swap. Basically, they swap, right? Interchange. So inverse will actually do this swap operation. Okay? Earlier domain becomes range for the inverse of the function, and earlier original range becomes the domain of the inverse function. Is this clear to you? Now, we have also written here one-to-one function. That means that if I have a function for x value, there should be only one y value, correct? Every x value should be associated with only uniquely with their y values. For example, what I'm trying to say is like this. If I have a mapping diagram like this, then each value is only associated with one. This is one-to-one function. So definitely going this side or that side, I will only connect these 2 points, and therefore I know exactly what will give me what, correct? So that becomes your one-to-one. On the other hand, if I have many to one, for example, I could also have a function which is like this, right? Now in this case, we know that both of them give me one value. For example, square, right? Let's say we have x square. So in that case, -1 and 1 will both give me 1, correct? Now, if I feed in 1, I don't know which value am I looking for. Is it this or that? It is not a function. Is that clear to you? So many to one function will not work. It may have an inverse, but the inverse will not be a function. Let that be the statement. So inverse is not a function. It will have an inverse. Inverse is not a function. So if it is many to one, inverse is not a function. But if it is one to one, inverse is a function. Clear? Right? So giving you example, for example, parabola, right? Its inverse is not a function, and this is kind of a square root. Its inverse is a function, right? You will see that this is not a function mainly because for one y value, we have two x values. Do you see that? So we say it fails horizontal line test.
So basically, one output can have two inputs. That's just what the it confirms.
Yeah. So that is the basic concept. And with this, let's move forward and take some examples. And as I was saying, that I will tell you in a minute how do we really find the inverse of a function, right? So I'll tell you 4 different ways of finding inverse of a function. So we'll go with the first method, which is swap the coordinates, because we've seen you have to change x to y and y to x to get the result, correct? Simple as that. So if I have a function whose inputs are -1 output, this is a function -1, -1, 0, 1, 1, 3, 2, 5, correct? 2x plus 1 we got these values, correct? What will be inverse of this function? Just swap. Make y as x and x as y. So, well, the first one, which is -1, -1, remains as -1, -1, right? This is same, correct? Well, these points which are same are called invariant points. They do not change. They are exactly same on the function and also on its inverse. Now look at the other point. You see, in the next point, which is 0, 1, now 1 has now become the x value, 0 has become the y value. Do you see they are swapped, correct? So it is the inverse. 1, 3 will become 3, 1, 2, 5 will become 5, 2. So you can see the inverse is a function whose x and y values have changed. Perfect. So this is a very simple way of getting the inverse of a function, especially when we know the coordinate points, correct? So when coordinate points are given to us, that is the way to do it. Now let us look into the algebraic method. So in algebraic method, what we do is we swap x and y, and then we isolate the value of y. So we had the function f of x as 2x plus 1. Writing f of x as y, we get y equals to 2x plus 1. Now to find the inverse, we will swap input and output and then isolate the output. So instead of y, I am writing x, correct? Instead of x, I am writing y, correct? That is the first step to find inverse of a function. Second step is we need to isolate y. So what did we do? Just took this 1 to the other side, x minus 1, then we divide by 2, and we got the inverse of this particular function as x minus 1 divided by 2. Simple steps. Are these steps clear to all of you? So that is the expression which we used earlier to verify that it is indeed an inverse, correct? So we have the same expression as we had earlier, correct? And we have verified that it really works with the inputs for the given example, right? Now here is a very good method of finding inverse of a function. And I say this is kind of a reverse operation, right? So Vishruta, can you tell me, if I say f of x is 2x plus 1, if x is the input, what do you do first to it?
You would have to make it into a fraction
Times 2,
divided
right?
by 2.
So to calculate the value, if I give you x, then you first times it by 2 and then you plus 1, correct? You get the value of f of x, correct? That is how you find the value f of x. Now, what is the reverse operation? Reverse operation is looking it from this side. So reverse method is, if instead of plus 1, we'll do minus 1 and then we'll divide by 2. We'll just do the reverse of the operation. Welcome, Ankita, to the class. How are you?
I'm good. How are you?
Very good, very good. So we are doing inverse of a function. I think, Ankita, you have a bit of introduction about it. So we have just done the introduction and we are continuing with it, okay? So there are 4 ways of finding inverse of the function. The very first is when you're given the coordinate points, you swap x and y value and you can get inverse of a function. The second method is the algebraic method, where you swap x and y. That is the first thing. We were finding the inverse of y equals to 2x plus 1. That is the equation on which we are working. So first step, we swapped x and y. So we get x equals to 2y plus 1. Now isolate y. Taking 1 to the other side, we get x minus 1 equals to 2y. Dividing by 2, we get the value of y as x minus 1 over 2. And that becomes the inverse of our function, right? Are you familiar with these steps, Ankita? Ankita, you are familiar?
Yes.
Yes, that's what. Now
Yes.
we are doing the third method, which is reverse operation. So 2x plus 1 really means multiply by 2 and add 1. Reverse operation is subtract 1, divide by 2. Is that clear? While going forward, we went times 2 plus 1. Coming back, minus 1 divided by 2. You get x. So that is what I did. Minus 1 divided by 2, you get inverse. So easy. Without using any algebra, just reversing the operation, we get inverse of our function. Did you see this third method, how easy it is? Given a multiple choice test paper, you can simply write down the answer by reversing the operation. Is that clear? And we can do it with
I have a
very,
question.
yes.
If the test paper asks you to solve it algebraically, would this work?
No, then it says algebraic method, you have to do algebraic. If it says what is the inverse, then you can this and write down the answer directly as shown here. You write the forward operation is times 2 plus 1. Inverse operation will be minus 1 divided by 2. And the answer is f inverse is x minus 1 over 2. Is that clear?
Thank you.
Fourth method is graphical method. If I am given the graph, for example, you could always sketch a graph. So the green graph is for the function y equals to 2x plus 1, right? So we know that the y-intercept is 1 and the gradient or the slope of this curve is 2. And we get this straight line. How do we find inverse from the graph? We have to find the mirror image over y equals to x, reflected on the line y equals to x to get the inverse of a function. So reflection on the line y equals to x gives you the inverse. I will show you how. Well, the point which is having the same x and y value, they will not change. They will remain same, correct? Because xx or aa, even if you flip, it remains a and a. So there is one point which will be intersection of y equals to x and any given line. That will be invariant point. Now, let's look into some other point. So for example, this point is what? This point here is 1, 3, right? Now, 1, 3, inverse will be 3, 1. So go to 3 and then see where 1 is. There you go, right? So if I connect, I get my inverse function, straight line. Do you see that? And this is actually the mirror image on this line. So this is mirror image. So by reflecting every point or just swapping and then connecting, we get graphically inverse of a function straight away. Is this clear to you? Step, all the 4 methods, right? Very good. Let's move on and take up some questions based on inverse function. First question is, f of x is equal to square root of x. So we have the square root function, which is shown to us in this green graph. And as you can see, x value is greater than 0, y value is greater than 0. We know this, right? Now, how do we sketch the inverse of this function? Yes. Mohammed, can you tell me the methods of finding inverse of square root of x?
You could sorry, can you hear me?
Yeah. Okay, wait. We'll ask Hamza. Doesn't matter. You can put your speaker off. Hamza, can you tell me different ways of finding inverse of this function square root of x?
I think the easiest way is that you see that orange line right there.
Yeah.
You can reflect over that, or you could just find 2 coordinates, 4 coordinates.
Yeah. Okay. Very good.
And then just
Correct. So we have square root of x, which is 0, 0, 1, 1, right? 4, 2, correct? 9, 3, correct? And inverse will be, f inverse will be 0, 0 will remain, 1, 1 will also remain, both are invariant.
Yeah, and then 2,
4, 3, 9. Is that clear to you? So we can connect and get this red line as our function. Algebraic method is slightly tricky. Now let us see the algebraic method. So y equals to square root of x. I can square both sides, right? I get y square equals to x. I can isolate x equals to y square becomes my inverse of this function, right? Or I could swap and do it. Let us do swap and do it, right? Y equals to square root of x. I'm swapping x equals to square root of y. And then I square it. X square equals to y. Do you see that? I get the same result. x square equals to y, or y equals to x square, right? So I'll write from here, f of y is x square, right? Is that clear to you? Now, if I just write, let me, because that is the correct answer. You notice I've also written that x is greater than 0 and y is greater than 0, greater than equal to, correct? That is the correct answer. But if I do not write this restriction, then what happens? If I write y equals to x square, then what is the graph of y equals to x square? This also, right? But that is not the inverse function of square root x. Only this is the right answer. So you have to write the condition that x is greater than equal to 0. Only the right side. Is that clear to you? If you do not write this part, then your answer will be wrong, because that means that you are giving the whole parabola as inverse of this quadratic, as inverse of this square root function. Do you see that? So if you are doing a function which is restricted, you have to give the restriction on the inverse also for perfect answer. Clear? Otherwise that answer will be wrong. So that is what is important. Consider domain and range of the function when you do this, okay? Now here is another related question, which is kind of the reverse. We'll now work on a parabola. F of x is x squared. How do we find inverse of this? Well, the process which we know is simple. We'll swap input and output. So instead of y equals to x squared, I'm write x equals to y squared. Now, let me isolate y. So whenever you square root, you have to do plus and minus. And once you do plus and minus, the inverse of the function will be the square root function plus side and minus side both, which is not a function because it fails the vertical line test, as we have seen earlier on, correct? So it is not necessary that inverse will be a function. Inverse may not be a function of a function. Do you see that? Okay. Now, let's take more examples. That was just a quick question. Now, here we have a function. F of x is equals to x squared, where x is less than equal to 0. Now, when you get this equation, what will be the inverse of this function? Can you tell me, Vishruta? What is the inverse of this function?
You would take the swap and input output method by using the graph.
Yes. Algebraically, tell me algebraically. Algebraically, I have done here. Swap input output, isolate the variable. X equals to y square. Then I wrote here y equals to minus x. Why did I write minus x? Tell me. Explain me this part. And that is the graph, which is correct answer.
You wrote minus x because the range says that y is great, that 0 is greater than or equal to y.
Okay. In the first case, yeah, you're right. Range is greater than equal to 0, correct? So therefore, that becomes the domain of the function now, correct? That becomes the domain of the function, correct? Which is x is greater than equal to 0. Okay. How about the range? But why am I writing minus 1? Minus 1 is because the domain is x less than equal to 0, right? So the range will be less than equal to 0, which is of the negative side of x. Is that okay now? So remember, this equation is y square equals to x. So if I say, what is y equals to? Y equals to square root of x with both plus or minus. Since we are given that x is less than 1, we will not write plus, right? We will take only the minus side. And therefore, the answer is this part, which is f of x is minus square root of x. Do you see that part? Extremely important, and that takes care of the condition, which is x is greater than equal to 0 and y is less than equal to 0. Is this clear to you? All of you? Okay, next question. I like one of you to read this question. Ankita, can you please read this question and answer?
Consider f of x equals x square root x plus 1. Write domain and range of f of x. Find inverse. Do you want me to answer?
Answer first one, yeah.
Okay. Domain is x is equal to all real numbers such that it is greater than, is that -1?
-1 is correct. Yeah, because that makes it 0, right?
Yes.
You have to write x plus 1 has to be greater than equal to 0. So x is greater than equal to -1. That is how you get the domain, right?
Okay.
Yeah, and y is greater than equal to 0. Correct. We got this. So when you want to find the inverse of a function, I know that we also have here C part is write domain and range of inverse, right? So immediately after doing this A, first you do C. Because you can straight away write down domain range of the inverse of the function. Is that correct? So Ankita, what is the domain range of the inverse of this function?
It would be y is greater or equal to 0. Oh, sorry. Y is less than or equal to 0,
No,
while
x will be greater than
oh,
equal
right.
to
Okay.
0.
Sorry.
This is
Sorry,
the
I messed that up. I was
-2.
looking
Yeah.
at 2. And then, yeah, x will be greater or equal to 0.
So first thing first, find domain range of the function, flip it, swap it, and write domain range of the inverse function. So you have answered 2 parts. Is that okay? Now you get into finding inverse, right? Now let us see how do we find inverse. Okay, Hamza, tell me what is the inverse of this function? F of x equals to square root of x. Use the word method. If I feed in x, what do? I will add 1 to it and then do square root, right? So we have a block, right? So I am feeding in x. So what do I do first? I will add 1 to it. And then what do? We do square root, correct? And then we get output y. Is that clear to you? So what is the reverse operation?
Okay, so what you would do is that you're doing the square root. So first you do is you subtract 1 and then, I mean, you'd square it and then you subtract 1.
First you square and then you subtract.
Yeah, and then you subtract
how easy it is? You add, you got this domain and range. Then you write down that x is greater than equal to 0 and y is greater than equal to -1. You are 100% correct. Is that clear? Because x square minus 1 basically is a graph which is kind of like this. But we are only looking for the part which is greater than equal to 0. That means we are only interested in this graph.
Sorry, I just had one question, and it's like a really basic question, but I just wanted to
ask. No, ask. Yeah.
So for the range, you found for the original function, you found y is greater than equal to 0. How did you do that? Because I just completely forgot how you found.
Because square root is always positive. Square root is always positive.
Okay,
right?
so because I know how to find the domain, like that's really easy. You can just put in the x value. But how did you find the
range is because it is always positive. Second, you can see the graph which I have drawn here.
Yeah.
That graph tells you straight away, right? So there are different ways. But square root function, parent functions, you know, right? And the transformation is 1 unit to the left. Nothing happens to y value. And there is no reflection. So it is still greater than equal to 0. Correct?
Oh, okay. Okay.
So you have to go back to parent functions always. And then transformation, second step. Then you know it. So combine those two. And this is the inverse now. Okay? Now,
okay.
Tell me, find the value of f inverse 10. How will you find the value of f inverse 10? Hamza.
So we already found our new kind of operation. So we can just plug in 10 and then
we get 99 as our answer, right? 100 minus 1 equals to 99. Is that clear to you? So we got all this. Clear? Not difficult at all. Very good example. This is just the solution to show you different ways of doing it. So as you have already seen, we could always reflect the graph on y equals to x and find our values, right? This is -1 here, the given graph, and the green graph is one side of the parabola, positive side, which gives us the inverse of this particular function, right? Okay. Now, here's a very difficult question. I would like you to focus on this and see how do we find inverse of a rational function? This is probably the most difficult question which you're getting in your test paper. So here we have f of x is x minus 1 over x plus 4. Okay. Now, first thing first, what is the domain and range of this function? Hamza, can you tell me the domain range of this particular function x minus 1 over x plus 4?
Okay, so the domain of the function would be x of all real numbers. X is X is greater than or equal to 4.
Not equal to.
Not equal. Oh, okay.
Because there are vertical, you have to look into vertical and horizontal asymptotes. Is that okay?
Yeah, okay.
Denominator-
I was just trying to, because the idea is to set the x plus 4, you can't be equal to 0, right?
Yeah, you are right.
Okay.
X plus 4 is not equal to 0, so x is not equal to minus 4. Correct.
Okay.
How about y? Y is not equal to what?
Y cannot be equal to 0.
1. Because this is different. X minus 1 over x plus 1. It is not 1 over x plus 1. Is this different? So we're looking for these coefficients, and their ratio should not be is what their value is. Now, this is not an easy way to figure it out. I'll teach you different ways of doing it, but let me show you how we could do actually. So I'm showing here x minus 1 over x plus 4, right? Plus 4. Now, because I have x plus 4 in the denominator, I want to know where my horizontal asymptote has moved. So what I will do here is, in the numerator, I will add 4 and subtract 4. See the technique. X minus 1 was there. What I did was, I added plus 4 and minus 4, right? So that means I didn't change the equation. It is just 0, right? Is that clear? Denominator is x plus 4. But by doing so, what have I done? I've got one factor as x plus 4 over x plus 4, correct? Minus 1 over x plus 4. Do you see that? And what is the first one? 1 minus 1 over x plus 4. Do you see this? So that means, and we know this is one term which is telling us that our vertical asymptote is at minus 4. So x cannot be equal to minus 4. How about the horizontal asymptote? This is the value. Because this will never be 0. So therefore, we'll never get 1. Correct? Do you see how we got range will not be equal to 1? All of you? Vishruta, is this step clear to you?
Yes, sir, it is clear.
So that is how you're going to find the horizontal asymptote, but there are many easy ways which I'll discuss when we discuss rational functions later, okay? So you can understand why we were not getting into inverse, because there are techniques to find inverse function, but here I've shown you how to do it. Is that clear? Now we know x and y limitations on this function, and therefore we can answer part C, which is right domain and range of f inverse x, right? You're getting equal marks for those parts. Why not fill it up, correct? Just swap it, and in this case we'll say, well, in this case x is not equal to 1 and y is not equal to minus 4 for the inverse. Is this clear to you? We've done this part. Now we have to see how do we find the inverse function actually. So we have to swap and then do the needful, correct? So let us go through that solution. So first, let me just show you what we did. So the first one was the function itself. Here, the red graph is the graph of the function, which gives you the vertical asymptote as minus 4, correct? And the horizontal asymptote at 1, okay? This is 1 for you. This is not 0 because this is 10, right? So the red graph is this particular function, and we have just seen that the domain and range is, that domain is all real numbers, but it does not include minus 4, and range is all real numbers, but it does not include plus 1. And therefore, for the inverse of the function, we swapped and write down domain and range. So we did part A and C first. And now we will see how do we do part B, which was to find the inverse of the function. Now look here carefully. We have this function which is y equals to x minus 1 over x plus 4. What is the first step? Swap x and y. That is your first step, right? So first step is swap x and y. So you see that, what did I do? Instead of y, I wrote x, correct? And instead of x, I wrote y. Is this step clear to you? Swap x and y. Then cross multiply. So when you cross multiply, you get x times y plus 4 equals to y minus 1. Now bring the terms together, combine the common terms, right? So first you open distributive property, multiply with each, and you get that. And then you bring y's together, correct? So distributive property. Now combine like terms. Is that clear to you? So when you combine like terms, you get y, right? So isolate y. And then y is, you can divide by x minus 1 and get your result. Do you see that? And you get your result, which is f inverse x is minus 4x minus 1 divided by x minus 1. Is this clear to everyone? Perfect. That is how you find inverse for a rational function, right? And then you could always write, you have to write domain range, which we did earlier. But anyway, that is how you're going to do. And this is the way to work with inverse of rational functions. Okay. We'll do inverse of exponential and trigonometric functions later. Okay. So we got this way of doing it. And here is the alternate method, as I tried to show you, right? So what I did was I added and subtracted 4. This is a technique, very good technique. Okay, not explained in books. This technique is not explained in books. Okay, so we are having x minus 1. So in the numerator, I added and subtracted because I can see x plus 4 in the denominator. We'll cancel it out. And so we got this particular factor, which is 1. Do you see that? Since I know this, I got this expression. And from here, we got, actually from here itself, this is also the correct answer. I mean, this is the function. Okay. But from this function, we get domain and range. That is your horizontal asymptote. And this vertical asymptote. Is that clear to you? But it's a very good technique, right? Now, inverse, you can actually do the inverse verbally using this statement. What are you doing? If I feed in x, first thing what you do is you add 1 to it, right? You add 4 to it. And then you do the reciprocal, then multiply by 5, then you take away from 1. And you do the reverse operation, you will get that slightly more complicated. So we'll not go into this. But anyway, learn this technique to find horizontal asymptote or working with rational functions. Okay. And then you have to adopt this technique to find inverse for a rational function. Okay, so let's take up more examples. Here's a very good example, and this is the last example for us. The question here is, which of the following rational function is self-inverse of a function? Self-inverse, do you understand? Means same equation. Function and its inverse have exactly same equation. Do you think it is possible? There are many examples. Let me give you many examples first, okay? For example, if I draw a line which is y equals to x, if I reflect the line on y equals to x, I get the same line, correct? X equals to y, same as y equals to x. Is that correct? Self-inverse. Is that okay? How about this line? What is the equation of x-axis?
Y equals 0.
Y equals to 0, right? Now, if I reflect this line, then what happens? There is no x value, right? So I cannot really swap, right? So y equals to 0 remains y equals to 0. Okay, let me take another line, which is perpendicular to this. Y equals to minus x. If I change, I get what? X equals to minus y, which is same as y equals to minus x. Is that clear to you? Self-inverse. I'm giving you examples of self-inverse. Is that okay? Other example, 1 over x. If I change x and y, what happens? X equals to 1 over y. It is same, right? Y equals to 1 over x. Self-inverse. Do you see that? All these are self-inverse. Let me give you the last example of self-inverse. Any line which is perpendicular to y equals to x means slope is negative 1. So I could write equation as y equals to minus x plus something k. Now minus x means it is perpendicular to y equals to x. So there will be a point which will get reflected on the line itself. So that will be a self-inverse. For any value of k, k belongs to real numbers. You see that example? So I've given you 4 examples. These are all self-inverse. All. So there are many functions which are self-inverse like this. Now, let's get back to our real question, and which is, okay, Hamza, can you read the question, please?
The second B.
Okay. What do you think is the right answer? Which of the following rational function is self-inverse? How will you do it?
Um,
You will go with each and every function and find out their inverse and figure it out, right? That is one way of
Mhm.
doing it, correct? And you know how much time it
but
takes.
that, yeah, that's gonna take a long time. I'm thinking of a shorter way, but I can't think of anything.
Yeah.
Because
I
I think
mean,
on a test you only have like 2 minutes to do multiple choice. So, I
yeah,
don't
yeah,
know.
yeah. So we should know the trick to do it. Otherwise, we are gone. Correct?
Yeah.
Yes. Let's go to the trick. Okay. There are many strategies. Okay. So strategy number 1. So what I did was, instead of doing one by one all, I have taken a general function. Do you see that? Y equals to x over a plus x over b. I am doing one function, x over x plus a and x plus b. I have, because the values are either plus 2 or plus 1 or minus 2 plus 2, combination of 1 and 2, right?
Yeah.
There could be any other number. Who cares? We will do x plus a divided by x plus b, general. So generally, I will just swap x and y values, cross multiply, simplify, and I get y equals to minus bx over x minus a. Is that clear to you? What do I get? I get minus bx plus a. Now compare these two equations. I want them to be same. I want them to be equal. How can they be equal? Minus b times x. So b should be minus 1. Only then it will be x plus a, correct?
Yeah.
And that works. So b equals to minus 1 works. Is that clear to you? So the denominator b plus b and this is minus 1. It works. Do you see that?
Mhm.
So that means this is the correct answer. Numerator could be anything. So if you have x minus 1, that is the self-inverse. Other numerator can be anything. Numerator could be x minus 700, whatever you write. But if I have x minus 1 here, it will be self-inverse. You get the idea. Okay. So this is very important question. It will waste 10 minutes, 15 minutes of every student, but for you, it is 1 second. X minus 1 should be there in the denominator to get the inverse. And that is my general solution to find inverse of a rational function where we have two linear in the numerator denominator. Is that clear to you? And it gives you a general way of solving this particular type of equation, right? Okay. So whatever we have learned so far about polynomials, the rational functions will be our next function to get into, but I think you're ready for it. And we have also seen how to find this. Now, very important question for you is, this is the ultimate question, right? Which is kind of, you can say as a homework, I'll tell you to, let us say, okay, let's take this example and tell me how this function can be transformed from y equals to 1 over x. What is the parent function here? Parent function is 1 over x, correct? You tell me, can you write down the transformation of this function? Let's do it on previous. Yeah, we'll take up this page, right? So now we are considering transformation. New question for you. This is tips. Thinking question, very important question from any test point of view. Okay, tell me, how has the function 1 over x transformed into the function? You can pick any. We'll do this, x plus 2 over x minus 1. Can anybody suggest and tell me the transformation from there to this place? Yes, please.
Okay, so obviously there's no vertical stretch or there's no vertical compression. So I think there's only translations here is what I can see.
Yeah, for sure, one translation, you know that the vertical asymptote has moved to position 1, right?
Mhm.
1 unit, right?
Yeah.
That you are sure about. Well, what is the, I mean, the horizontal translation is you sure about that the vertical asymptote has moved, right? Except for that, other you don't know. I'll now show you the technique of doing it, which I have already shown you once again. What we will do, we'll use the method x plus minus 1 is in the denominator, right? So I write minus 1 plus 1, and then we have already 2 in the numerator and x minus 1. Do you see that? So we have x minus 1 over x minus 1 plus, what is 1 plus 2? 3, right? So 3 over x minus 1. Is that clear to you? And this is what? This is 1 plus 3 over x minus 1. Now you can tell me the transformation. Do you see that? Now, Hamza, tell me what is the transformation of this function. We are transforming from 1 over x to this function, which is 3 over x minus 1 plus 1. Yeah, tell me.